The land where your city stands today hasn't always been in this spot. If we could rewind the clock by 200 million years, the ground beneath your feet would embark on a journey across the globe. This is Pangaea, Earth's most recent supercontinent, shown with modern international borders projected onto the ancient crust. The coast of Nova Scotia was physically connected to Morocco. Southward, Brazil fits into Nigeria like a fractured stone. Even Florida was originally a fragment of Africa. Our political maps feel permanent, but geography is not static. Earth is a dynamic system that is constantly rearranging its own surface. Beneath the soil and the sea, Earth's outer shell is fractured into massive slabs called tectonic plates. These slabs float on the mantle, a thick, scorching layer of rock that flows like cold honey. Early observers called this continental drift, imagining landmasses plow through the sea. We now know the process is more complex. The continents sit on these larger plates, and it is the entire plate that moves, carrying the land and the ocean floor along with it. The engine for this movement is heat. Intense thermal energy from the Earth's core creates convection currents in the mantle, slowly dragging the plates across the surface at about the same speed your fingernails grow. When the crust begins to tear, it follows the path of least resistance. Geologists call this structural inheritance, the tendency for the Earth to rip open along ancient scars left behind by previous collisions. This inheritance explains the origin of Florida. When Pangaea split, the crust fractured along a line that left the Florida platform attached to North America, while the rest of the African plate drifted away. Decoding the flow of the mantle allows us to see exactly why the surface breaks where it does. As plates move apart, they create rifts that eventually flood with seawater. This is how the Atlantic Ocean was born, growing from a narrow crack into a 5,000-mile-wide basin. This model shows the mid-Atlantic ridge, an underwater engine of growth. As the plates separate, magma rises from the mantle and cools into new crust, meaning the Earth is continuously rebuilding the ocean floor from the center out. In some other areas, tectonic plates collide head-on. With nowhere else to go, the crust buckles and thrusts upward, creating mountain ranges that can reach 5 miles into the sky. When one plate is forced beneath another, the rock melts and vents back to the surface. These eruptions provide the most visible evidence of the intense pressure building at plate boundaries. When these massive plates get stuck and then suddenly slip, the release of energy triggers earthquakes that can fracture the very streets we drive on. These collisions and eruptions act as the planet's primary recycling mechanism, constantly venting internal heat and refreshing the mineral composition of the crust. When Pangaea fractured, the growing rifts divided animal populations. Species that once shared a single habitat found themselves stranded on separate landmasses as the oceans widened between them. This isolation forced life to adapt. As continents drifted into new latitudes, animals faced different climates and predators, which branched the tree of life into radically different directions on each continent. We see the proof in the fossil record. Identical remains of ancient reptiles and plants are found today in both South America and Africa, remnants of a time when they occupied the same forest. Modern proof comes from oceanographic research vessels like the Kazakh Explorer. These ships use high-resolution sonar to map the features of the seafloor that are hidden miles beneath the waves. By mapping features like the Churley-Gibbs fracture zone, geologists can measure the exact distance the continents move each year, confirming that the Americas and Europe are still drifting apart. This movement dictated the placement of every habitat on Earth, determining which regions became fertile plains and which became impassable mountain ranges long before the first migrations began. The journey of the continents is far from over. The internal heat of the planet will continue to drive the plates into new configurations over the next several 100 million years. This projection, called Pangaea Ultima, predicts that the current oceans will eventually close, bringing the Americas, Africa, and Europe back into a single massive landmass. The ground beneath us feels immobile, but we are simply living through one small moment of a billion-year process. Our modern map is a temporary snapshot of a planet in transition. If you could walk across the ancient borders of Pangaea today, which neighboring country would you visit first? Let us know in the comments below.